Aim of the experiment is to sort a given set of n integer elements using QuickSort method and calculate its time complexity. Objective of algorithm is to demonstrate QuickSort method using Java and how the divide and conquer method works along with its time complexity analysis. Here we need to consider worst case, average case and best case efficiencies. Steps involved in quicksort method are: first step, consider the first element of a array as pivot element. Define two variables I and j. Set I and j to first element after pivot element and last elements of the list respectively. Increment I if pivot greater than least of I. Otherwise, stop the increment process. Step 4. Decrement j if pivot is less than least of j. Otherwise, stop the decrement process. Step 5. If I less than j, then exchange least of I and least of j. Step 6. Repeat steps 3, 4 and 5 until I greater than j. Exchange the pivot element with least of j element if I greater than j. Now consider algorithm with input. Consider an array A of size 4 which is unsorted. Here consider first element in the array is 50, second element is 10, third element is 70, fourth element is 60. A of 0 represents 50, A of 1 represents 10, A of 2 represents 70, A of 3 represents 60. Here low is pointing to index value 0, I is pointing to index value 3. 50 represents the pivot element and I is pointing to 1, j is pointing to index value 3. Step 1. Consider first element in the list as pivot element. Therefore, here pivot equal to 50. Next, set I and j value. Here I is set to low plus 1, j is set to I. Increment I if pivot is greater than a of I. First, we need to compare 50 with a of 1, that is 10. 50 greater than 10. So therefore increment I value. Now I value is 2. Next, once again compare pivot with I. 50 greater than a of 2 means 70. The condition is false. So stop increment process. Then decrement j. If pivot is less than a of j, here pivot is 50, a of 3 contains 60, therefore 50 less than 60. Condition is true, therefore decrement j. Now j is pointing to 2. Next, once again compare pivot with a of 2. 50 less than 70. Condition true, therefore once again decrement j value. Now j is pointing to index value 1. Next, once again take pivot element, compare with a of j. Here 50 is less than 10. The condition is false. So stop the process. Next, step 4. If I less than j, here I value is 2, j value is 1, 2 less than 1, condition false. So don't swap a of I with a of j. Next step 5, if I is greater than j, yes, condition true, therefore swap pivot element with a of j. Here 50 and 10 are swapped. So 50 position is fixed. Next, in the same manner, we need to process left hand part. Left hand part contains 10. Right hand part also we need to process. Right hand part contains 70 and 60. The same concept is applied to these two parts separately. The application of QuickSort is to sort student list according to USN. We can use QuickSort. Sort the item names according to price at the shops. We can use QuickSort. Now we'll see the execution of algorithm. First statement is package statement. After specifying package statement, then next we need to import java.utility.scanner for our reading purpose. Then after that we need to import java.utility.random for random numbers generation. Then next we need to start an algorithm QuickSort. To create a QuickSort algorithm, here create a class QuickSort. Then inside QuickSort class, we need to declare a method quick by using public void quick and passing parameters array A, low position and high position. Inside quick method, we need to check whether low is less than I or not. If low is less than I, in that case, we need to calculate the pivot element position. To calculate pivot element position, a call method partition. This method will return a value j that represents the actual pivot position in the array. This partition method will take three parameters. First is array, then low index value and high index value of the array. Next, after finding the actual position of pivot element, we need to sort left hand part separately and right hand part separately. Here left hand part is sorted by once again calling quick of a comma low comma j minus 1. Here we need to update I position to j minus 1. In case of right hand part, we need to consider array A and low position j plus 1 comma high position same. Initialize j by declaring int j. Next is partition method. Here it will return integer value, so therefore declare partition with public int partition. It will take three parameters. The first is array, second is low, then third is high. Inside this method, initialize variables ij, pivot, temp. I for incrementing I value, j for incrementing j value, pivot to point a pivot element, temp to store a temporary variable. Next, initialize pivot to flow means first element in the array is considered as a pivot element. After considering pivot element, then we need to set I position. I position is set by considering low value. Therefore, here I equal to low plus 1. Next, we need to set J position. J representing I. Therefore, here J equal to I. And after setting pivot element I position and J position, we need to increment I value and continuously we need to decrement J value in case of if I less than J. Otherwise, we need to swap A of J with pivot element and return J. After returning J, then we need to stop the execution of for loop. Here, first we need to write a code to increment I. So therefore, consider while statement inside for loop while pivot greater than or equal to A of I and I value less than I value. In that case, increment I. Next, we need to write a code to decrement J. We need to decrement J when pivot is less than E of J. Therefore, here, while pivot is less than E of J and J must be greater than or equal to low means immediately decrement J. After incrementing I and decrementing J, then compare I with J. If I is less than J, in that case, swap A of I with A of J using three statements. Temp equal to A of I means assign A of I to temp, then A of I equal to A of J, then E of J equal to temp. Here first copy E of I to temp, after that copy E of J to E of I, then at the end once again take the content present in temp and store in E of J. This will swap a content present in E of I and E of J. Otherwise means if I greater than J means swap pivot element with E of J. Here pivot element is represented by A of low. Therefore, A of low is swapped with A of J. Then return J. By returning J, here we are terminating for loop. Then next, we need to move to a main class, public class QuickSort demo. Inside this main class, we need to initialize a main method, public static void main string args. So inside main method, create an object, QuickSort object that is given by QuickSort q equal to new QuickSort. Then create a random object for random number generation that is done by random of r equal to new random. And after creating random object and QuickSort object, then create one-dimensional array by using statement int a of square brackets that is equal to new int of 10,000. This will create an array A with a size 10,000. Next, initialize I and n. So after this, we need to read n value from user. So for that, create scanner object. After creating scanner object, then print one statement for user, enter the number of elements. After that, take the n value and store in variable n using nextInt method of a scanner class. Then we need to generate n number of random numbers. To generate n number of random numbers using object R, here use for loop. This for loop will generate n number of random numbers. So after generating random numbers using statement a of I equal to R into next int of 1000, then print the generated random number using system.out.println. Here R dot next int of 1000 represents uh, the generation of random number. The random number must be within 1000. Next, after that, record the start time of the algorithm by calling system clock. To call system clock, here use statement system.current time millis. Then store the start time in variable start time of data type long. Now after storing start time in long variable start time, then call the QuickSort algorithm by using object q. Q dot quick of a comma low value is 0, I value is n minus 1. Then after executing the algorithm, immediately stop the recording of time. To stop recording of time, once again you need to take system time. To take system time, once again use same statement system.current time millis and store the end time in variable end time. Here total time taken by the algorithm is calculated by subtracting start time from end time. That gives what? The total time taken by the algorithm. After calculating total time taken by the algorithm, then print the sorted elements of an array using for loop and system.out.println. So after printing elements in an array, then print total time taken by the algorithm by using system.out.println once again. This completes a program. Now we'll see the execution. Save the program. Program saved. Then click on run. Here program asking enter the number of elements. Here first give 5. Yes, random number generated by the program are 943, 722, 186, 726, 203. The sorted elements are 186, 203, 722, 726, 943. And time taken by the algorithm is 1 millisecond. Like this, we need to execute for more than 5,000 elements. Then we need to record time. We need to repeat this for at least 8 readings. After taking 8 readings, then plot a graph for number of elements versus time taken. That represents the time complexity of QuickSort, which includes worst case efficiencies, best case efficiencies, and average case efficiencies. This about QuickSort algorithm. The conclusion is we can use this QuickSort algorithm to sort elements in the array. Thank you.